Good day, Dr. I'm Yoke, and I'm going to do a demonstration for Lab 2 for question 1. So I'm going to start the debugging process. Okay, so over here we have two variables, and then we are having the code. So at first the registers are not initialized for EAX and BX, and so now we move to line number 1, and we are going to move variable 1 into AX, so we can see AX is going to be 0001. And then next, we are going to move variable 2 to BX as well, and now we are going to exchange AX and BX, and so we can see at AX is going to be the value of variable 2, and BX is going to be the variable of variable 1. And now we are going to move back AX into variable 1, and there will be no changes in the register, and we're going to see the outputs. Okay, so variable 1 is going to be now 9 right now, and next variable 2 is going to be 1. And finally, let's dump registers, and we can see that, okay, over here we have the register AX is still 009, and BX is going to be 0001. Okay.
Good day, Dr. Rashida. Today I'm going to present about Lab 2 question 2. So first we start debugging, step over. So now you can see the first line, move EAX X file. This means we move the value of X file into the register EAX. So value of X file is 26. So execute line 1, EAX has been changed to 26, and the register here too, it has changed. Then we negate EAX. Negate EAX means to become the 2's complement. So EAX, after I execute line 2, EAX has been changed to the 2's complement, which is negative 36 in decimal. So next, we move EBX Y file, means we move the value of Y file into register EBX. So Y file is 30. So the register EBX now is also 30. Then we subtract EBX Z file. So it means we subtract the value of EBX with Z file. So Z file value is 40 here, and EBX is 30. So we subtract it and store it in EBX. So EBX now should change to negative 10. So EBX here in the register, it has also changed to negative 10 in hexadecimal. Okay, then next line, line 5, we add EAX, EBX, means we add these two values and store it in EAX. So should add together. So EAX should now be negative 36. So negative 36 in decimal. In register is hexadecimal form. Okay, now increase EAX. So EAX value will be increased by 1. Okay, the register has changed. So EAX here is also changed. Then the last one, line 7, we should reset move R value EAX. It means we will move the value of EAX into R value. So R value is now being defined. Initially it is 0. After that, it has been changed to the same value with EAX, which is negative 35D.
Now I'm going to do the demonstration for question 3, and over here we have 4 variables, and below here we have the code. And so I'm going to step over. Okay. So at the registers, okay, the registers are not initialized. And first, okay, we are going to move variable 1 into EAX, and so we can see that EAX have turned to variable 1, and the EAX is going to be 5 hexadecimal. And next, we are going to multiply EAX with variable 2, and therefore we can see that it changes its value to 32, to 32 hexadecimal. And EDX have changed to 000, as because when we do multiplication, they may be EAX may not be long enough to store value, and so it will be storing in EDX. However, in our case, it is enough where we can see it's 32 hexadecimal. And then we are going to add variable 3 into EAX, and so we can see that EAX have changed to 46. And finally, we're going to decrease EAX by 1. So we will see that EAX become 45 over here. And so that's all for this program.
Now I will try to execute Lab 2 question 4. So now we start debug. Okay, so we have 3 variables, which is variable 1, variable 2, and variable 4. So let's step over. So first initial value we have AX, variable 1, and variable 4. So line 1, move AX, variable 1, bar 1, means we move the data of bar 1 into AX. So now we execute line 1. So bar 1 has been moved into AX, which is 40. So now line 2, move BX 5, means we move the value 5 into BX. So BX has become value 5. Then mul BX, line 3. So line 3, mul BX, which we will multiply BX with AX. So now we multiply BX with AX, and the value is stored into AX. And move BX bar 2 means we will move the value in variable 2 into BX. So variable 2 is 10. Now our BX become 10. Okay. Next, subtract BX 3. So we will subtract the value of BX by 3. So BX, the value is stored in BX and becomes 7. Then divide BX means we divide the value of AX by BX. We divide the value of x by bx, and the quotient is stored into ax, which is 28. Then the remainder is stored in the register dx here. Okay, then line 7, move bar 4 ax means we move the value of ax into variable 4. So the value of ax now is 28. So variable 4 should be 28.
Next up, I'm going to do a demonstration for question 5. So let's start over. Okay, so right now over here you can see again the registers are not initialized. And so first we're going to clear dx. And let's start over. And you can see that the dx is being to 0000. And next we're going to move 1000 hexadecimal to ax. And you can see that there's changes over here. And then we're going to load 25 hexadecimal in the cx. And over here we can see that it's changed. And finally we're going to multiply ax by cx. So you can see that it changed to 500, but actually that's still it's going to be 35,000. So as because the length is not enough in AX, it's going to combine with DX, AX, and so it will be over here. And finally, we're going to call down register, and we can see in our terminal, this is the registers. Okay. And so that's all for question 5.
So now I'm going to continue to question 6. So debug, step over. I post this. Okay, so first we have this line 1. Move dx 0 means we clear the dx to form 16-bit dividend. So we execute line 1. You can see dx has become 0, 0, 0, 0, 0. Okay, then move ax 803h means we load the dividend, which is 803 hexadecimal, into ax. Execute. Okay, you can see eax. The 803 has been loaded into the register eax. Next, move bl 10 hexadecimal. Yes, now we will load the divisor into bl. So now, okay, so the divisor has been moved into bl. Then divide bl. So we will divide the dx with ax by bl. So then after the divide, we will store the quotient into al and remainder into ax. So execute line. Okay, you can see the quotient has been stored into al and the division has the remainder has been stored in h.